conditions. So it is also called other subroutines, such as the push program unknown, which I've also renamed it. And we can look at, actually it has imported a function called load library A, which is being used when which is called where it will load the specified module into the address space of the calling process. And with this, we can assume that the malware might be attempting to use the subroutines to create the software path registry key and or to open the software path registry key if it exists. Then it would create a new registry key within the path, and it will set a new value for the new registry key and then load the program and library within it. And now we'll look into other subroutines. So now we'll look into create file A. And upon clicking it, we can actually saw that this imported function create file A is being called in this particular subroutines. Yeah, and it has also loaded some local variables and arguments. And you can see that lstr length A is being called, and it would actually help to determine the length of the specific strings, which in this case is used to determine the length of IP string. And then it will be used to compare against. And there's also a jump condition using compare between register EAX and 104 hex. And if 104 hex is greater or equals to register EAX, then you will jump to log42E 8cc, else it will not take the jumps. So we can see that if the jump is not taken, you will actually call another subroutine, which I have renamed it as get full path. And this will be discussed later. Then it will use a test condition between register EAX and EAX. And if the result is 0, it will actually jump to log42E 8cc. Then, as we can see, if it does not jump, it will actually conduct a number of comparisons. As you can see, there's a lot of comparisons, which I'll not go into the details. And moving on to the more important part, which is the part that calls the imported function create file A, this. And create file A is actually used to create a new file, and it can be seen that it actually pushes the required variable and its value to create the new file. And after calling it, it uses the compare condition between register EAX and this hex value to check if the file is created. And if the result output is 0, it will not jump, as it will actually jump to log42E 8DD. Start, which will eventually exit if it actually jumps. So if it does not jump, we can actually see that it will follow this path, and eventually it will call another imported function called get last ever, which will retrieve the calling thread's last ever's code value, and eventually it will reach an unconditional jump to log42E 8cc, where there will be a XOR between register EAX and EAX, then it will go to log 42EBCE. As shown here, then it will call another subroutines called load library, which actually we have analyzed just now. Okay, so now we'll move back to the get full path subroutine, which we have saw earlier. So upon clicking it, okay, so for this particular subroutine, it actually calls the imported function called get full path name A. And get full path name A function is actually used to retrieve the full path and file name of the specified file. It can be seen that it actually also uses functions such as the get volume information A, which will retrieve information of the file system and volume associated with the specified root directory as well. As we can see that it actually also calls path is UNCA functions, which determines if a path string is a valid universal naming convention path. And with this, I can say that this particular subroutine mainly retrieves more information about the input variable, which is the file, and it can get information such as the full path name and volume information. And with the subroutines that we have analyzed, we can assume that the malware will attempt to query a full path to create a file using create file subroutine and load a certain module in it using the load library subroutines. Next, we will look into the subroutines that calls the function write file. Okay, so we have found it. So we can see that this particular subroutine actually calls the imported function write file. So upon clicking it, we can see it here. Okay, so there's also quite a number of arguments and global variable sets, and there are many conditional jumps using compare, as shown here, which I will not go into very details. So as we can see, if the output result of the comparison between register ECX and 0FC hex is 0, it will actually jump to log for 3201, else it will not jump. And when the jump is not taken, it can be seen that it has actually called the get module file name A function, which will retrieve the fully qualified files for the files that contains the specified module. And it has also called some offset value called a program name UNK, which refers to the string's program name unknown. And it has also performed some increment of value in register EAX and called some other subroutines. So moving below, we can actually see that it has pushed some offset that might want to show some error strings and the type of library is going to use, such as a Microsoft Visual and a runtime error PR. Then you can see that it has also imported another subroutine, which I renamed it as load library user. Then it will end with an unconditional jump to log 432301. So now we'll move back to the portion with lots of comparison, which is here. Okay, so if the jump is actually being taken, if the jump is being taken here, it will actually enter this particular log423.1D9 process, and we can actually see that it has actually called this imported function called getSTD handle to retrieve a handle to the specified standard device, and it has also called the write file functions, which writes data to the specified file. And we can actually see that it has also loaded this particular offset 445A94, which actually contains the strings that states that floating point is not loaded, and actually eventually all those processes would end up in log423.201, in which it will call the load library subroutine, which we have already discussed earlier, and it will also pop EDI, ESI, and EBX. So with the subroutines analyzed, we can assume that the malware is actually checking if the reference file that has set to run at startup in the victim system exists, and if it does not, it will likely be due to the antivirus, which will remove the file. This would cause the malware leaving behind a registry entry or startup items pointing to a file that does not exist, which would cause the floating point not loaded message to appear, and we will assume that the malware might be checking for the error message and will want to rewrite the reference file such that the malware could run normally again. So next, I'll look into a subroutines that calls the file find extension A. Okay, which is here. You can see that the subroutine that has called this particular functions here. So since we know that the malware is likely to be a parasite based on the virus total report that we have looked into doing basic static analysis, so we want to look into this particular imported functions, which is pathfind extension A. And we can see that it has actually called another imported function called getModuleFileName, and it is used to retrieve the fully qualified path for the file that contains the specified module. And it has also conducted a conditional jump using a test between registered EAX and EAX, and if the output result is 0, it will jump to log431BDC, else it will not jump. And if jump is not taken, you have another conditional jump between registered EAX and EBX. And it will jump to 431BDC as well. Else it will also not jump. Then moving on, we can see that it will actually push some required variables and call file path extension A, which will search a path for an extension. Then it will conduct some moving of bytes from strings to string, as well as calling the offset ASDLL.